Now, another reaction intermediate is your carbocation, which is also known as your carbonium ions, carbon having positive charge on it. Now, what is the definition? Now, these are the species containing positively charged carbon atom. Okay. Now, how it is formed? These are formed by heterolytic fission. For example, if you see 𝗂𝗏𝗏𝗏 CH3Br. Now, here what happens, because bromine Br is more electronegative than that of carbon, so it attracts the pair of electron towards itself, due to which this becomes CH3 plus, carbon having deficient center, and Br becomes Br minus. So, carbon having positive is known as methyl, this is CH3 plus, so it is methyl carbocation or methyl carbonium ion. Now, carbocations are highly unstable and reactive species. Okay. And carbon atom is of the carbocation, it is C plus. This is your sp2 hybridized, and due to which the structure is trigonal planar structure. They react with the nucleophilic reagent having a pair of non-bonding electrons. Obviously, they are electron deficient centers. That is why they that means they react with the nucleophilic reagents. And what is the order of reactivity? The order of reactivity of carbonium ions is primary. Carbonium is greater than secondary, is greater than tertiary, which is the reverse order of the stability. Normally, the stability of the cations is influenced by three effects: positive inductive, hyperconjugation, and resonance. Now, on the basis of positive inductive effect, greater is the number of plus I groups, because alkyl groups shows the positive inductive effect, plus I effect. So, greater is the number of alkyl groups, or greater is the plus I effect. So, greater is the stability of the carbonium ions. So, now the reason which जो कि मैंने अभी भी आपको एक्सप्लेन किया, अल्काइल ग्रुप इज इलेक्ट्रॉन रिलीजिंग ग्रुप प्लस इफेक्ट रिलीजेस द इलेक्ट्रॉन टुवर्ड्स द कार्बन atom and reduces the positive charge on the carbon atom. So that is positive charge get dispersed and hence destabilize the carbocation. Stability increases with increase the number of alkyl groups. Okay. Now next point is in the order of that means influence of hyperconjugation. What is the order? The tertiary is greater than secondary, is greater than primary, then methyl group. Now see here one important point is here in case of tertiary carbocation, tertiary butyl carbocation. Here see here in this example you will see how many. This one is your main carbonium ion, and this carbon is your alpha carbon. This is alpha, this is alpha. So the hydrogen attached to alpha carbon is your alpha hydrogen. So in total there are how many alpha hydrogen? 9 alpha hydrogen. Greater is the number of alpha hydrogen, greater is the hyperconjugated structure, greater is the stability of the carbonium ion. So here in this tertiary case 9 alpha hydrogen atoms are there. But in case of secondary, see here CH3 CH3H. So here 2 alpha carbon means 3 alpha hydrogen here, 3 here. So total 6 alpha hydrogen here. In this case CH3 matlab 1 alpha carbon, 3 alpha hydrogen, total 3 alpha hydrogen. Here there is no alpha hydrogen. So due to this the order is like this. Okay. That means, see, alpha hydrogen takes part in the hyperconjugation. So greater is the number of alpha hydrogens, greater is the hyperconjugative interaction. Hence, greater is the stability. And tertiary carbonium ion has more number of alpha hydrogen atom. That is then secondary and primary. That is why the case. Okay. Now, influence of resonance. If you will see, example, allyl and benzyl carbocations are much more stable as they are stabilized by resonance. Allyl carbocations here. This is an example of allyl carbon. That means allyl compound where if you shift the double bond here, this forms the carbon deficient is here CH2 plus, and this structure arises. So there are two possible regenerating structures. Due to this, the allyl carbocation is stable. Now, benzyl carbocation, you will see regenerating structures, greater is the stability of the carbonium ions. So that is the reason why due to greater number of regenerating structures, benzyl carbocation is more stable. Okay.